time for our Finest NGC's corner?
Yeah, let's do it. Okay, what I'm going to do here is I'm going to turn off these markings. I'll just turn off that marking here. And so as always, what we're trying to do here is march through the winter NGC objects. I'm just going to bring up my bookmarks. And I selected, I've got 5 to show you this afternoon. Put this over here like this. And so, you know, we're trying to see these objects when they're culminating or close to their highest point in the sky, because that's when we're viewing them through the least amount of Earth's atmosphere. So this week we have a moonless evenings, and we've got the sky getting dark. I think I said it was at astronomical twilight is finished at 7:30 p.m. So let's put the sky to 7:30 p.m. Looking south, we've got, of course, Orion, Taurus, Auriga. And then if we flip this around and look north, then we've got Polaris, Ursa Minor, Camelopardalis, and then so on. So we've got the green Z is the zenith overhead. So first up, we've got the Flame Nebula. The Flame Nebula is in Orion. So I'll bring this into view. Completely super easy to find it because it's parked right beside the eastern star of Orion's belt, Alnitak. It's a relatively bright combination of emission nebulosity and dark foreground dust that is breaking up the larger patch of nebulosity and producing these sort of enchanting shapes. So some people think it's a flame, some people think it's a maple leaf. I read somewhere it was nicknamed the tank tracks. I'm not sure what that's from. There's the Ellipse Nebula, Burning Bush, Ghost of Alnitak, that sort of thing. So it was discovered by William Herschel back on January 1st, 1786. It was his class 5 object number 28, so B-28. I've seen people claim to be able to see its glow in big binoculars from a dark sky. Don't know how reliable that is. But really, I recommend, say, if you've got a 4-inch or bigger telescope and a dark sight, then you should be able to pick it up. Obviously, super easy to find it because you just need to point your telescope 1/4 of a degree to the east of Alnitak. You probably want to actually hide the bright star outside the field of view just to help you see it. I'm just going to show you the simulated view. So this is the 6-inch Dobsonian telescope through a 26mm eyepiece, and that gives you kind of the field of view. It's actually about 30 by 30 arc minutes, but the brightest areas are a bit less than that. But you can maybe with a bigger telescope see a bigger size to it. So what you're going to look for is the orientation and the shape of the dark dust. As I said, you can magnify it at, say, 35x, or maybe even, let's just go here to double that. Let's try the next one, 14mm. So, 65x would probably be a good magnification. I didn't find that a filter, an ultra high contrast filter, helped me very much, but you could certainly try it. You want to look for the shape, the dark dust. You want to note its any sort of picture you image it, or picture that you imagine, or maybe you could sketch it. And don't forget that Alnitak itself is a double star, so you can split that and look at that when you're there. And that the Horsehead Nebula, which isn't really a visual target. It's one of the RASC's challenging. I think it's one of the challenge targets, but it's nearby as well. So that's the Horsehead. Okay. Next up, we've got the Kissing Crescents Nebula. This is a planetary nebula, and it's in the northern part of Orion between Betelgeuse and the head, Meissa. And one of the ways that you can find this object, and I did this last night, is put your telescope on Meissa. So we'll just do this. And let me just change the magnification back down to the 26mm Plossl. So this star pattern is very, very recognizable. You've got Meissa, Hecate, and a line of 3 stars connecting them. Then from here, you're going to hop in this image to the right, but it's actually to the east, to Phi 2 Orionis, and then keep going a little bit further. You're going to pick up this little pair. And eventually, let's see if I can put on the symbol here. Once you've got this little pair, then you can pick up NGC 2022, the Kissing Crescents Nebula nearby. Now, this is a really tiny object, so I didn't see it last night. I looked, and I didn't have my O3 filter to brighten the planetary up, but I didn't have a lot of eyepieces available to zoom in too much. But I would say you need a medium to large aperture telescope to really enjoy it. You really do need to magnify it a good amount. Let's see, I suggested to crank up the power beyond 100x if you have it. Just sort of simulate that here. We can go to 14, and I'm just going to actually put a Barlow on this. So you can start to see the little shape, little disc of it as well. You can, yeah, if you have an O3 filter, you can brighten it with that. You want to use averted vision. You might be able to see the blinking effect where it gets brighter and dimmer as you look at it and look away from it. And I think if I zoom in a little bit more, I'm just going to come out of this and zoom in manually. So it's a really cute little object, but you really have to crank up the power to see the details. So you might be able to pick up the central star, and you might even be able to pick up some of the non-uniformity to the structure. So do note that, and then, you know, enjoy the rich star field around it at the same time. Next one up is now changing horses. We're going to go into the northern sky. So let me just flip this off. So that's two objects in Orion. We're going to flip around and go into Camelopardalis. And we're looking at here is the Oyster Nebula or Camel's Eye Nebula, NGC 1501. So let's just go here. And this one is actually right near Kimball's Cascade and the Jolly Roger clusters. So if you see these two corner stars of Camelopardalis, if you can see this line of stars here, that's the Kimball's Cascade chain of stars. And then you've got this little clump here, that's the Jolly Roger cluster. And once you've got this one, then you can pick up the Oyster Nebula in the same neighborhood. So let me just zoom in on the Oyster Nebula here for you so you can see it. As planetaries go, this one's a little bit strange because it doesn't have that shell kind of characteristics that we're used to. This may be because it's a relatively younger planetary that hasn't had a chance to kind of expand out and differentiate as much yet. It should be visible in any size of a telescope. It's about magnitude, it's brighter than 11.5. It's more like 10.5 magnitude. If you want to see its form, though, you really want a larger telescope. So what I recommend doing to find it is to, I'll just swing back here. If you take Cassiopeia and you draw a line from Cassiopeia to, let's see, Segin, the last star, so the first to last, and double that, that'll land you basically on the Jolly Roger. Once you're on the Jolly Roger, it's really only a thumb's width from there. So they'll actually share the field of view if you've got a low power, say a 1.5 degree field of view. So let me just put this in the eyepiece for everybody. There we go. So that's seeing it at about 125x. So you really need to crank up the power to see it well. You can use an oxygen 3 filter or a UHC filter to brighten it. You want to notice its size and shape, its orientation, and any structure you might notice, any nearby field stars. There are some field stars in the neighborhood. And then when you're there, don't forget to enjoy Kimball's Cascade and the Jolly Roger. So this thing's about 5,000 light years away. Okay, we got a couple more. Still in Camelopardalis, we've got an object that's called NGC 2403. It's actually one of the Caldwell objects. So that's kind of in an empty, featureless patch of Camelopardalis. This is actually a galaxy. And if you zoom in a little bit here, you can see it's relatively bright, really, really nice, pretty galaxy. It's visible from a dark site in binoculars, it's big enough to see in binoculars, it's about 24 by 13 arc minutes, so about the size of a half moon in basic dimension. Discovered by William Herschel back on November 1st, 1788. It was his object 5, class 5, number 44. It resembles the fireworks galaxy, NGC 6946 in Cygnus. Now, the way I found it was I used the star HR 2209. So where's that one? Let's just find this one. HR 2209. Right. So this star HR 2209 is a relatively bright star. And it's, if you look between that star and the nose of the Big Bear, so this is Ursa Major, this is the tip of the nose of the Big Bear, then the galaxy is sitting halfway between these two. So you can just aim your finder midway or binoculars midway and pick up the galaxy that way. Or you could take the line from Theta Ursa Majoris. So if I take the front kind of arm joint of the bear up to the nose and go about 1.6 times that distance, then that also will pick it up. So you've got a couple of options there. Let me just put this in the simulation for us. So there's the view at 128 power. That's probably more than you want. Let's just put this back to, let's take off the Barlow here. No Barlow. There we go. So it's about 65x. It's a good amount to view it as. Do you want to note the characteristics of the core, the shape, the orientation of the disk, the texture? Look for some embedded field stars. So there's actually some foreground stars in the disk of the galaxy. And then there are some nice surrounding stars as well that can really confirm the star field for you. All right, and last up, we've got NGC 2655. This one is also in Camelopardalis. This is sitting down near Polaris. So if we zoom in on this, get this really pretty interesting, pretty looking galaxy. So this is what's called a bright lenticular galaxy. It's a combination of kind of a lozenged plus some arm structure to it, some spiral structure, discovered by William Herschel back on September 26th of 1802, and he classed it as object class 1, number 288. Now the core is very bright, so you can really see that in any size of a good quality telescope. But if you want to see the nice structure around it, you're going to need a bigger aperture telescope. So it's not near any good helper stars, but what I did is I used the star HR 3751. So let me show you where that is. And again, that was a star I could see. That's kind of this orange star. And from there, I actually star hopped from there. So let me just highlight these so you can see where these are. I'll pick it up. There we go. So from there, I kind of made my way following the star patterns from there. You could also, another way of doing it is to take the Big Dipper's bowl. So I used, let's see, it's Megrez. And I split the difference, let's see, from Megrez to Lambda Draconis. So where is Lambda Draconis? So here. So if you take this star, in the corner of the Dipper's bowl, go to the tip of the dragon's tail and double that distance, and that'll bring you to the galaxy as well. So you want to use this one. Do your searching at low magnification. Let me show you the view here. And then once you've got it, you want to start cranking up the magnification to see a little bit more detail. So look for the halo around the bright center. Remark what you observe about the core itself, and you want to look at any orientation and shape that you might make out, and look for the nice little field stars around it. There are a couple of really bright little cute ones around it as well. And there is a galaxy in the neighborhood, NGC There are actually a few galaxies in the neighborhood around it. You've got NGC 2715 nearby as well, if you're in the neighborhood. So this one's about 80 million light years away. So that's it. That's 5 for this time around, and we'll stop there.
Perfect. We have just, if anybody has any questions about the finest NGCs, throw it in the chat. We have an unrelated question, and maybe people in the chat can also comment on this. Someone found the app called Dark Sky Meter and was wondering if it's worthwhile to test their skies, if it's decently accurate.
I'm not familiar with that. Is that measuring the sky, or is it reporting the light pollution data?
I think it's recording. I looked it up with, I think it might have to do with the light pollution side of things, like what your, like an SQL meter. So yeah, if anybody is familiar with that.
I haven't used it myself, because one of the main reasons is that I'm an Android user, and the cameras on Android devices are less kind of regimented as the Apple devices. So the Apple devices are able to be used more as a scientific instrument because they're more calibrated than the variety of cameras you get on various Apple Android phones. So I know that when I've spoken to developers of night sky camera apps and things like that, they always say, well, it's easy for the iPhone, but it's hard for an Android phone. So I've heard of apps that you can use an Apple phone, an iPhone, to almost for photometry, where you can measure an accurate light reading, but they're just too variable in the Android phone. So they can't make an app for every single device, so they don't tend to do it as much.
I will say, based on a quick search, RASC centers, there's a few, particularly on the West Coast, I've picked up that have advertised this app. From what I've heard in general, is apps are never as accurate as a real SQL meter if you're looking for the sky quality. But go ahead, try it. It seems like other people are using it, and as well. I see that, Chris, you've brought up the light pollution map here.
Yeah, this is one of my go-tos. It's the lightpollutionmap.info. I mean, it's great if you're planning to go somewhere and look, seek out darker skies. And one of the great things about this website is that you can actually select from a variety of different layers. So this World Atlas 2015 has got and if you mouse over, let me just pick this. If you click on area, then it actually reports to you, oh, there we go. It reports to you the SQM reading and the Bortle class reading. So you can actually query it to figure out, where you're going to go. Now, this is from 2015, yes. So there's another alternate layer on here. You can go to the various VIIRS maps. And these are kind of views from space of the light pollution. So you can kind of use this to look, what's happened in the last few years to a particular area you might be interested in going to. And I'm not sure if you can still click on a map. Yep. So you can get its radiance value. It's actually giving it to you over time, so you can actually get a readout of whether things are improving or not over time. So that's a really nice tool.
If you're interested more in your local sky quality, I definitely recommend connecting with members of your local center, because I know, depending on the center, some centers or have people in there that focus a lot on light pollution abatement. So they would be a very good resource to know what's up in your area. So
I'll hand it over to you now, Samantha.
Okay, well, thanks for you who stuck to the end. Little announcement. This will be my last Insider's Guide episode. So thank you all for being so welcoming. It's been such a fun year of doing this. I am departing from my role at the Royal Astronomical Society at the national office at the end of the month. I am moving into to another outreach education role in my local area. But thank you everyone for all the welcoming that you've done and all the insiders guides, everything you've come up out to. Thank you, Chris, for everything you've done. And I will be, if anybody's in the local Toronto area, I will be at the Outdoor Adventure Trade Show, which will be in Mississauga. That will be my last hurrah. My last days will be out there talking up RASC. And yeah, with that being said, I don't know if you want to talk about where Insider's Guide is going to be heading with that.
Well, let me just say first, what a heartfelt thanks I have for you and for Jenna before you for allowing me to come on and prattle on for an hour and a half every couple of weeks. It's been really great. As you mentioned, we've done 65 shows, and you've been great as a co-host. And I'm going to miss you like crazy, as I miss Jenna as well. And what we'll do is we'll decide whether we can proceed by finding another co-host. So if anybody has any ideas about how to go forward from here, we'd be happy to hear them. Please get in touch and let us know. But it's been a great run. Thank you so much.
Yes, thank you. And if anybody has any ideas, you can email outreach@rasc.ca. And thank you all for all your kind words. All the Insider's Guides folks get to be the first to hear it, so I appreciate everyone. And I will be still sticking around as an RASC member, so catch me when
Me too. I'm not going anywhere.
Chris is not going anywhere. Don't worry. You just won't see my face as much.
Yeah.
It's really exciting to now have the time to go stargazing and join star parties and all of that. So
yes, I promised Samantha I would get together with her and do some stargazing sometime.
got you. I still have to go to the DDO before when it's dark outside.
Yeah.
Only ever been there when it's bright.
Perfect.
Okay.
All right. Well, thank you, everybody. Thank you, Samantha.
Thank you so much. Have a great rest of your week. And
keep looking up.
Keep looking up. Yeah. Bye all.